All right, this video is for those of you who missed the 5C.7 notes in class. This is solving systems of equations by substitution. So if that's the one you missed, that's the one you should be watching. All right, so the lesson before this, we learned how to solve systems of equations by graphing. We graphed the equations on the same coordinate plane. So today we're going to learn how to solve systems of equations by substitution. So the method of substitution involves expressing one variable in terms of the other variable. Okay. This method is most useful when one of the variables can easily be solved for in one of the equations. Okay. So we've got this great flow chart right here that kind of walks you through step by step, how to solve these equations. So we've got an example. Let me zoom out a little so you can see. We got an example down here at the bottom. I don't know if I can get I'm not gonna be able to get the flow chart and the example in, but I do have a copy of the flow chart right here. So let me just kind of fold it over so I can get in here. Okay. So here's the flow chart, and I'll kind of refer back and forth to it, and then we're working on this one down here at the bottom, the very bottom of your page. Gosh, really? There we go. I'll zoom back in a little bit so that you can get a better idea of what we're doing. Okay, so we're doing this one down here at the bottom of the page. So it says, let's try, this is the same system that we solved for when we graphed on the last unit, okay? So we're going to solve this one by substitution rather than by graphing it. Shouldn't be too difficult, but it takes some getting used to. And so don't think that it's just going to come really easy, really fast, okay? All right, so my system, my little flow chart here on step one says, look to see if the variable is isolated. Okay, an isolated variable is one where it's either y equals or x equals or whatever variables you're using. It's got it all by itself on one side with everything else on the other side of the equation. Now, if I have a 3 here in front, this is not isolated. Okay, the only way it's isolated is if it's all by itself with nothing in front of it, nothing dividing it, anything like that. Okay, so we want to see, do we have an isolated variable? Well, if you look here, we have y equals right here, so we do. So what we want to do, now I'm going to use some colored pencils or pens here just so that it's a little bit easier. We're going to take, so we go over here to yes, and yes says, step 2, substitute the expression for the isolated variable into the other equation, and then solve for the leftover variable. Okay, so what that means is take what this equals, whatever isolated variable equals, in this case it's x plus 1, and we're going to substitute it into this other equation for y. Because y equals this, then we can substitute them, okay, since y equals it. So I'm going to bring this in here for y. So nothing else is going to change except this y right here in this equation. So the x plus 2 stays. Now instead of y, though, I'm substituting in x plus 1. And because this y and this 2 are butted up next to each other with nothing in between them right here, it means multiplication. So that's why I'm doing 2 times all of this, okay? And then that equals 8. Now, to solve for this, the first thing we have to do is we need to distribute this 2 to everything that's inside the parentheses. Okay, so when I do that, this x stays the same. I get 2 times x, which is 2x. 2 times 1, which is 2, and then that still all equals 8. Okay, so now what I need to do is I need to combine like terms. I'm still on step 2. I'm solving for the leftover variable. That's what I'm doing right now. I'm solving for x. My leftover variable is x. So I'm going to combine like terms at this one and this one. Now remember, when I have just a variable all by itself like that, there's a 1 there. So 1x plus 2x is going to be 3x. And then the rest of this just stays the same. So plus 2 equals 8. Okay, so now this should be pretty easy for you. This is just solving for x. In order to do that, we're going to subtract 2 from both sides. Okay, I get 3x equals, and 8 minus 2 is 6. I'm going to put this up here because I'm running out of room. So 3x equals 6. And then I'm going to divide by 3. X equals 6 divided by 3 is 2. Okay? So unfortunately, that's not all we have to do. Now remember, when we're trying to solve a system of equations, we're looking for the ordered pair, the point where these two lines intersect with each other. Okay, so far I know that they intersect at x equals 2. Now I just have to figure out what y equals. Now in order to do that, I'm going to take this 2 and I'm going to substitute it into x. So if you look here on your flow chart, step 3 says substitute the value for the variable from step 2, which is x, into the equation with an isolated variable, simplified to find the remaining variable. Now, technically, you can substitute this x into either one of these equations. It doesn't matter which one you use, but this one that says y equals is going to be easier because it's less steps. So I'm going to take this 2 and I'm going to substitute it into here. Okay? So what I'm going to get is y equals, and then instead of x, I'm putting in 2 because x equals 2, and then plus 1. Y is 2 plus 1, so y is 3. So they intersect at the point 2, 3. Okay, and if you think about that, I've been asking my classes, what quadrant does that fall into? Remember, when we're graphing, our quadrants have numbers. This is 1, this is 2, this is 3, and this is 4. So if it's a positive and a positive, it's going to be in quadrant 1. Okay, this is a positive, positive. If it was quadrant 2, x would be negative, but y would be positive because I come over into the negatives, but then I go up. Okay? If it's in 3, they're both negative because it goes into the negative and down, so negative, negative. And if it's in 4, x is positive, but y is negative. Okay, so, oops, not a 1. Sorry, I didn't mean to write a 1 there. That's something that you should kind of keep in mind. I might ask a quick little question like that on the test just to see like which quadrant would that fall into. It's a quick little easy point for you as long as you've got that written down somewhere. Oh, it's kind of, sorry, it's kind of cut off. There you go. Okay. All right, so if you flip your page over to the next one, we have another example. It looks like this. Okay. Now this one, this is just another example of solving by substitution, but if you look at our flow chart that we've been looking at, this first step says look to see if the variable is isolated. Well, if you look here, neither one of these are isolated, so we actually have to go to no. Okay, we go to no, and no tells me choose the variable that is easiest to isolate in one of the equations. So I want to pick one of these and isolate one of the variables. Now, if I was to try and take one of these and isolate them, I'm going to have to do some dividing because right now x is being multiplied by 3 or y is being multiplied by 4. And in order to get x or y by itself, I have to divide. I have to do the opposite. Okay, and then we're going to have fractions. So you always want to look and see which one's the easiest. This one by far is the easiest. So off to the side over here, we are going to do x plus y equals 4, and we're going to solve for one of these variables. Now, it does not matter which variable you solve for. You can pick x, you can pick y. So last time what we had was y equals something, and we substituted. This time, I'm going to solve for x, and we're going to get x equals something so that you can see that you can do it either way. So in order to solve for x, I just subtract y from both sides. Okay? What I get is x equals 4 minus y. Okay, so now I have x equals something, x equals 4 minus y, and I'm going to substitute that into this equation. I can't go back and use the same equation. I got to use the other one. I'm going to substitute this in for x. Okay, because x equals it, so I can exchange them. All right, so we're going to do 3 times and then 4 minus y, and then we just write the rest of this down. Plus 4y equals 10. Oops, I meant to write that in purple. This should have been purple, sorry. All right, so now what we're going to do is we're going to distribute the 3. So 3 times 4 is 12. 3 times negative y is negative 3y, and then this stays plus 4y equals 10. Okay, now we're going to combine like terms. This negative 3y and this positive 4y are like terms, so we're not doing anything to the 12, so I'll just rewrite it. And then a negative 3y plus a positive 4y will give me a positive just y, and we don't write the 1. Okay, and then that equals 10. And then to solve for y, we just subtract 12 from both sides. So y equals negative 2. Okay, so over here when I've got my point going, this is y, this is negative 2. Remember, my ordered pair is always x comma y. Okay? All right, so now that we have y, we're going to take what y equals, and we're going to substitute it into any of these equations for y. You can use this one, or even this one that you kind of manipulated over here. Now this one's already in the form of x equals, and x is what I'm trying to find. So I'm just going to take this and I'm going to substitute it right in there for y. So I'm going to get x equals 4 minus, and then negative 2. Okay, don't let that fool ya. That's still a minus and still a negative. And remember, when we minus a negative, it actually turns into a big old plus sign. Okay? So we've got 4 plus 2, so x equals 6. So then 6 goes here. And the point they cross is 6, negative 2. Now, if I were to ask you what quadrant that falls in, 1, 2, 3, or 4, remember, it's a positive 6, so it's got to be one of these ones. But since it's negative, it's going to come down here. It's going to be in quadrant 4. We use Roman numerals for those. Okay, so now this pause and check is for you to do on your own. So this you're going to solve by substitution, and then once you're done solving it by substitution, you're going to come over here and you're going to graph this same system, just like we learned before. And you're going to see if the point you come up with when you solve by substitution is the same point that they cross at when you graph. And they should. If they don't, something's wrong. Okay? All right. That is 5C.7. Thanks, guys.